Hey, folks, I'm David Fields, and this is the first we're attempting to schedule viewing of a meteor shower, which is probably overly courageous anywhere in the world, but especially in Tennessee. So the first two meetings, I think, will be okay. The third meeting is going to be an attempt to actually choose a good night. And of course, you probably know that means low light pollution and no clouds and no moon and forget the food and coffee and drink and things like that. But most importantly, meteors. I think we can take care of the meteors. So that's to be done. All the scheduling and everything is controlled, hopefully, by Jim and Becky Rushton. So way to go, guys. Way to go. Lots of moving targets here. Anyway, I think this will be fun. And all of you are invited to ask questions anytime or contribute. And especially next week, I think that I'd like each of you to, if you've got a meteor story or something you want to talk about regarding astronomy, feel free to do it. This is a first for us. We're not only having this meeting, which is something I haven't been associated with meetings in person for a while. It's also virtual. So we're having a go at a virtual session also. This is the Orion videographer, Rob Fowler, and he's done a lot of professional videography, and he gets all the credit. Way to go, Rob. He also accepts money, but no, he any work opportunity. Yeah, right. But he does really fine things, and he's been handling the Orion meeting for some time. We've kept up our Orion astronomy / education / physics meetings through the COVID crisis. And of course, that's the elephant in the room, the Delta variant. So I think all of you folks are doing the right thing. I mask when I go out. And if I mask and mumble, there are problems. So I'm trying not to do either at the moment. Is it audible in the back? Okay, guys. When you ask questions, if you will, say your name, and hopefully that will let the people watching know about it. People that are watching can send messages by chat, and Rob will laugh or delete or tell me about them, tell us about them, and we'll go ahead from there. So what you're seeing is a combination of Tamki Island Observatory astronomy activities. We operate the observatory for the community and for the students, and of course ORICL. And I think all of your members, so all of you got all the emails about the course except me. I got some of them today. I learned some things. And Orion you're all invited to become active participants in Orion. You can be a participant without paying, and nobody quite figures it out. Or you can join and pay $20 a year. So that's an opportunity. Okay, June 28th, we're closing in on one of the meteor showers of the year. And that's kind of interesting because there's so many ways to avoid it. If everything works out, it can be very spectacular. So what that means is you see things that you remember for a long, long time. Now, that's with everything optimized. It may be a time exposure as well. But the height of the Perseids typically is like 60 meteors per hour. A meteor is asteroid. Most of them, everything in astronomy has exceptions. I wanted to say meteors are leftover pieces from the early solar system. There are exceptions. Some things are from outside our solar system, but very rarely, and it's hard to verify that. There have been recent entries from distant places. Anyway, these asteroids are present. Some of them are in orbit, associated with Jupiter, some with other planets. Some are captured and even ascribed to the category of moons, like the moons of Mars are probably captured comets. Others actually enter the Earth's atmosphere. Countless numbers of them are small, and they filter down as dust and small particles. And you can put a pie pan out and along with some dust and residue from fossil fuel plants, you'll get a few meteors. So in one of my classes, my students had access to a scanning electron microscope. And with that, you can get soft X-ray emission from the electrons and identify some of the minor elements, the little specks. And you can say, oh, look at that one. That's high-end iridium, things like that. So that gets interesting. And you can look at them and characterize. So countless fine particles. A few of the particles that come in, a few of the asteroids are big enough to not only become incandescent, but to actually light up. And we call those not asteroids, we call them meteors. They streak across the sky like this. Once in a while, so far we're into astronomy. Some of them streak across the sky, and I don't want to do what I usually do in lectures because the camera's there, but they streak across the sky, and they do that. They actually land, and they enter a different domain, the domain of geologists. And geologists can call them by their special names, like rocks. Or they put the ITE on them, like meteorite. So I think that's sort of good. They're rare, but they're far more than we know. They're hard to find because they look pretty much like rocks. And if you want to find them, there are a couple of places on Earth you can go and find them. Because you can find places there are no rocks. There are certain regions in the Sahara that there are almost no rocks. And the guys there, some of them make a living. The nomads, they pick up the rocks they find, and most are meteorites. There are other places where they're not only very few rocks, but there are forces in nature that gather them up and concentrate them. Like I told my grandson, there's really no magic, but there's physics and chemistry and stuff like that. So that's where the rocks are falling on glaciers, and the glaciers move, and then they melt, and they keep moving and melting. So in these regions, in the Antarctic, you can find some meteorites. And if anyone wants to go, I can go. I think about that. It could be an interesting trip at the right time of the year. Okay, we see something like this. We'll be fortunate. This is not from Tanki Island Observatory, although it's a nice little observatory. And one of our decisions is going to be, and I think Jim and Becky have been talking with you, what do we do when we want to see the actual meteor shower? This will be the Perseid meteor shower. And there could be Perseid meteors tonight, it could be in a month, but most of them are concentrated around August 11 and 12. That's particular residue from a particular comet, and that orbit is out there now. The residue is trapped in our solar system. When that orbit and the Earth's orbit cross, that's when things happen. And they're always crossing, coming from a particular direction, which means a particular constellation. Anybody know what that is? Yeah. You got to say it with confidence. Add it, of course, or something. But yeah, it's the Perseus. And Perseus, the hunter, it's a fascinating constellation. Go look into the mythology, and he's got one hand out, one hand up, and the hand that is up like this supposedly carries the severed head of Medusa. Crazy thing. But there's a little eye socket there. You look at the eye socket. This is true. You look at the eye socket, and it's just a nice blue star, but it gets dimmer and dimmer, and it becomes a little red pinpoint. So that's pretty spooky. So it's a variable star system, blue, not blue, blue, not blue. And there's an associated red star. So when it's not blue and it's dim, you can sort of see the little red star. But it's a good thing to make people believers, I guess. Yeah. Uh-oh. Okay. Thank you. Shall I repeat something? Oh, okay. Please feel free to tell me again. And I'll keep speaking clearly and try to make it clear. Anybody else? Any other thoughts? Okay, lots to cover, and it's just a fascinating topic. So we've known for a long time. Sorry about that. We have known for a long time, haven't we, that meteors fall from the sky. Going back to the Bayou Tapestry, lots of history, lots of accounts of meteor falls and comets. We know things happen in the sky. Every educated person. Well, I don't know, Tennessee, the US, this is Tantalum Observatory. That's what the sky usually is. And this is the best site we have around as far as being reasonably dark sky site. This is about midnight. You're seeing clouds illuminated from below. So it's very unusual to have everything just right. This is a good night for a meteor shower, but not the best night for viewing. So every educated person knows what rocks do not fall from the sky is the way it was. And a person I greatly respect said, I would rather more easily believe that two Yankee professors would lie than that stones would fall from heaven. And of course, the European astronomers had a different viewpoint. But the person I respect greatly, Thomas Jefferson, said that. And he was trying to be a practical person, but he was a very educated person, the highest caliber thinking. And he had to be convinced about the absurdity that goes on with meteors. As I mentioned, there are many asteroids, there are many meteors, but the special ones are the ones that arrive at predictable times. And they are associated usually with the residue of comets. So if you have an Earth-crossing asteroid, or an Earth-crossing comet, not the Earth-crossing asteroid, that would light things up eventually a great deal, but an Earth-crossing comet orbit, then there will be associated with that a lot of asteroids. These asteroids are what is going to become meteors. Now, some comet orbits are hyperbolic. They zip through the solar system. One example is Oumuamua, the asteroid that crossed a year and a half ago from a distant place. We don't know the origin of. But these comets that zip through once can be spectacular, but they can generate meteors. The ones that, for some reason, such as bypassing Jupiter closely enough, can have their hyperbolic or parabolic orbits perturbed. They can go into an elliptical orbit and obey the Keplerian equations very nicely, and stay in our skies. And they normally, most likely, are in the ecliptic. The ecliptic is the plane of orbit of the planets that orbit the sun, because most of the stuff in our solar system ended up with angular momentum. That angular momentum ended up being the plane of the planets and the sun. There are a lot of collisions. So you have things like the Earth's spin axis is tipped 22.5 degrees, such as the moon's orbital axis doesn't coincide with the Earth's spin axis. Things like Uranus being tipped over 90 degrees, all sorts of things like that. So from this chaotic beginning, still there's some regularities that we still see. Lots of things happen. And by the way, if you're worried about the big one, if you're worried about big impacts, it's probably not going to be this rocky residue from some comets. It's going to be something that was kicked out of the Oort cloud being this residue of old leftover material way out beyond Pluto, or even something that's kicked out of the asteroid belt, which is a lot of rocky material that orbits the sun between the orbit of Mars and Jupiter. Any questions? Okay. Anything on the chat? Ron? Thank you, Herb. Yeah, John. Okay, Jim asked the difference in a comet and an asteroid. If the comet has been in the inner solar system orbiting for a while, I guess the difference is maybe the origin, maybe the comet came from outside, but the chemist might say that. The astronomer might say it's in the behavior. The comet, excuse me, the comet would usually have gaseous emission and tails. That comes about from being far out in the solar system, where there's a lot of leftover light, low density materials. This means water, carbon dioxide, carbon monoxide, cyanogen, a lot of stuff like that. And obviously lots of sulfur, lots of hydrogen. And these things are frozen, so they collect on anything orbiting there. Anything that comes in from the Oort cloud or anything that goes out starts collecting this stuff. And it's a cold body. If it comes in toward the sun, we say it's coming in. When it heats up, it develops a tail or two or three or four. It can have a tail because the material is ejected in different directions. But more than that, there's likely to be one tail of gas, which kind of is emitted and takes different direction because of the solar wind. So it's pointed away from the sun as the comet orbits. And then there's a matter trail which isn't affected as much by the sunlight. It's a bit different. It's like you often see two tails, and the tails show the composition. So that's the comet. And meteors come from asteroids or comets. The surprises come from the big asteroids and the big comets. The surprises we don't want. We might want to see them, but we don't want to see them too closely. So if any of you are watching things and you see something streaking across, it's and someone else is looking in that direction, it's polite to say, look at that. If the person beside you is looking in a different direction, it's not polite to say, oh, this is a joke. To say, oh, you missed it. Also, if you see a bright one, it doesn't seem to move. But it seems to be bigger and bigger and bigger and bigger. It's probably polite to say duck because I haven't seen that, but I've always kind of been ready. Sometime I might see that. A train, sky train. Yeah, thanks, Rob. Okay, anybody else? Okay, this is what happens with the big one. This is a little place, a little patch in the woods where something made an impact. It did not land, it exploded. And what it probably was a comet. Now, many of them don't come in. They kind of skim off and bounce off the atmosphere. The one that affected, I think it was Chelyabinsk in Russia a few years ago, kind of did that, but its total energy was about 20 kilotons of TNT. Fortunately, it was not one big boom. Fortunately, it was not close to the ground, but there was a succession of booms. This one is Siberia, 1908. Excuse me. And the area affected was about 400 square miles. It's really something big. So, and you can sometimes expect these big ones. You can plot frequency of events versus size. There are not many big ones. One of these is every 100 years or so. The big ones, the really big ones that could destroy the planet, then not destroy, but seriously affect life on the planet. Maybe once every 100 billion years, something like that. A lot of hand waving, but we don't get the big ones very often. But as I said, it cut quite a swath in Siberia. Barringer Crater in Arizona is quite interesting to see from the sky, to look at the history. And it's been explored greatly because there was a possibility that there was an iron meteorite, probably was, based on the small pieces that are found. And there was a possibility it could be found close to the surface and mined. So people thought that, they dug. Later they said, oh, but of course, look at the lakes forming from meteors hit. Look how they come in. It won't be below the crater, it'll be off to the side. So there's another meteor boom, like an oil boom or something, I guess, meteorite boom. But another attempt to find something profitable. And in the end, there was. Tourism is profitable, I think. Okay, so we're after the predictable meteor storm. And we can find those when we start looking at the comets. This is the Bayeux Tapestry. It's done quite a while. You see the comet. And this was of course, fraught with religious significance and caused trouble. But Edmund Halley, who wasn't trying to get funding for Isaac Newton, and he was just a generous individual as well as a good scientist. He researched the history of this comet and predicted its next occurrence. So Halley's comet has a lot of history. It's been researched, and just fascinating to know the history and study what it is. This shows some of what we were talking about, the dust and the gas trails coming from the comet nucleus. So you can remember the particle trail kind of goes along with the comet. It has more inertia. The gas trail very much affected with the solar wind and points toward the sun. Might be, that's not right. It points away from the sun, and you can see that sort of thing. So this is our comet, Comet Smith-Tuttle. It was first seen, excuse me, in 1962. We observed the pieces, and more or less August 10, 11, 12, 13. But in reality, these pieces are spreading out along the track. So we can see them tonight. We can see them just about any time. But to actually go out and expect to see several, August 10, 11, 12, 13. If you go then, you'll see probably, if it's a good night, meteorologically, you'll see some comets, and you'll see some that don't follow the expected behavior. The neat thing about it is the radiant is from Perseus. That means trace the trails back, and you find them converging on Perseus. So it's one that's considered maybe the best one to observe, 60 meteors per hour at its peak. And hopefully you're getting excited, but save it because we get closer to it. Lots of bright meteors. What's happening this year? A lot of these things are converging. It's a good meteor shower. The waxing crescent moon on that date will set early. We can find a dark location. After midnight, it's a problem. A really big problem. So I don't like to stay up that late, but I personally think it's worth going to a dark place. And that would be the observatory. But there are other dark places. They're far away. Things like that. But I want you guys to make that decision because I can do other things. Anyway, choose a dark location. We would start viewing. I think if it's any place like the observatory, the roads are interesting in your own county. We should arrive. I'll be there by 8 o'clock. And if that's where it is, and then you can come and relax. I promised the water will be on. It's been turned off. So bathroom, classroom, comfortable. You can bring a blanket if you like. Bring food if you like. I encourage you. Sure, food. Okay, so it's a good place, but things will not start happening in terms of meteors. However, you can see Venus in the west. You see Mercury in the west. I always tell my students, make them count the planets, so they cannot do it. It's not mathematics, but they forget Earth. It's the Earth. What you find about 10 is you're able to see Jupiter and Saturn. They're great. We'll have the scopes out. If it's not at the observatory, we'll bring scopes anyway. Try to have some around. Those are just great. And you can start seeing meteors, I hope. I would expect so. And it gets better and better. You can see them after midnight. But at some point, if you get sleepy, you know, that interferes. So we're not going to stay forever. You know, if you've gotten into it, like Rob does, gets up at some obscene hour like noon or something. I don't know. If you like that, hey, you can keep going and things would get better. 3 o'clock, 4 o'clock. Because not only is the Earth, not only is it dark, but the Earth's spinning motion is added to its orbital motion of the sun. And as it encounters this cloud of debris, there's a lot more velocity difference. And so if something comes in, it's heated up faster. So that you can expect things better if you're awake, coherent, intelligent, you know, things like that. Okay, so Saturn, Venus, Mars, I didn't mention. Jupiter's there. Mercury setting in the west. And the thing that you won't see, I guess, is the moon. The moon is actually nice, but we're not after the moon that night. Any questions? Okay. Where do you look? Well, you look anywhere in the sky, but I told you you have a radiant. Sorry about that. Poor laser technique. These trails seem to come from the direction of Perseus. So Perseus was the hunter, a little guy, you know, like this, rising in the northeast. And I kind of recognize the star pattern. Many astronomers don't look through telescopes. They look at the computer screen, but the ones that go out looking around the heavens and trying to appreciate the evening, see star patterns. The people that get into the classics see star patterns. There's the hero. There's poor, beautiful Andromeda. There's the end of Andromeda. Andromeda Nebula is right about here. That's a nice thing to see. We should be able to see that. And there's the Queen keeping an eye on Andromeda to be sure she doesn't have too much fun. That's Cassiopeia in the recliner up there. So you see this, but really look for something like this. Look for meteors, as I said, that have a radius that looks like these streaks emanate from the region of Perseus. And there's lots to see. So I'd like to get the amateur astronomers with us wherever we go. Any of you have any comments about location? Feel free to volunteer somewhere else. We don't have to go into this. This is an add-on. This is what to do in your spare time. Pull out an FM radio, build an antenna that has some gain, point it in the sky over toward, for me, over toward Nashville. Tune up a station you cannot possibly hear and listen. And you get little blips as the meteor trail bounces radio signals back down. Now that's an interesting thing to do. It's kind of fun. And I wrote it up and can tell you about it. But I don't have to show this to you tonight. Usually you can actually hear a little bit of the station going, the FM station. What I did was make a little modification on my radio. See, there's the circuitry attempts to keep the signal strength constant, so you don't have the levels changing. So it's got an automatic gain control. So I turned that off, and then I looked at the error signal, and then I got that sort of thing. I would hear the noise. It's just noise. There are other ways to hear it. You can look at the frequency change, and then you get whistles, things like that. And that's pretty interesting. You can even do it from here into Canada. On one station, there's one strong analog, not analog, there's one strong old style TV station, or two of them in Canada. And the audio section is amplitude modulated. It works really well. You can do that. But I was plotting it. And so I connected this thing up, and this is a short version, okay? So there's Nashville, and there's no way our system in Oak Ridge can hear Nashville FM because the signal goes through the ionosphere. But if there is this path doesn't exist unless something really ionizes the air, and that's what happens. A meteor comes in. There's my son. He's far taller than I am now. That's the way it goes. I made a little ugly antenna up in the tree, and pulled the wire inside, and I get these little blips, and that's an amplitude what one gets. And then you see strange. You see every time you make measurements, you see things that you don't expect. My thing that I did not expect was this: why should I see little wiggles like that? What I'm seeing is the interference signal from two different sources. What's going on here? And if you watch that, that's seconds down here. This is 1.7. This is all the way up to 10 or 15 seconds. And this is not meteors. Turns out it's multiple paths bouncing off of airplanes, that sort of thing. So when one gets stuff like that. And I think that's what's nice about making measurements. And those of you who work in labs, you know, make discoveries when things do not work. Because then you say, this is terrible. But it's not terrible. It means it's an attempt to understand something new. And it's fun to do that. So some of us are working on a satellite now. How do we put up a little satellite that could pick up signals that we cannot possibly hear because these signals are bounced off or absorbed by our ionosphere? And then we say, what do we want to hear? Well, sure. Put a computer on it, let it calculate the spectrum of the signals that are coming in. That's kind of the obvious one. But what else? And it's the stuff we wouldn't expect. That's probably interesting. Anyway, it'll be entertaining to go out and search for meteors, because you don't just watch for meteors, you watch the strange people that are seeing things in the sky, and myself included. Yeah, that's the way it's going to rise. Oh, it'll be coming up that night. The point is, you probably won't see any meteors in that constellation. What you will see is the streaks going all the way across the sky, or going. So you can say, I can't see it. Well, right, that's okay, because you just kind of keep an eye to the northeast. Now, if you like to suffer, or you can stay up late, and Perseus climbs in the sky, and about 2 a.m. it's up in the northeast. It won't be very high, but it's like that. Then you can say, hey, look, and see, if you're lucky, you can see other trails. And the radiant, that is the direction from which they originate. I'll do it this way. The direction from which they originate is Perseus. But initially, you don't see anything but, hey, it's there below the horizon. Somebody told me, it's interesting to get an app on the phone. If you've got an iPhone or an Android, and these apps most are free. I have several and play with them. Some I like for one thing, some for another, and I can tell you what they are if you like. And once you have those, you can bring it up and hold up your phone, and you can see what constellations you're looking at, what planets, things like that. So that's fun. Sure. I can tell you now, but it's better I email them. You won't have to write them on your palm and all this stuff. Okay. Yes. Oh, it's great for motion. Averted vision for motion is great, and yeah, it's really good. The central part of your vision has a lot more resolution. It's got a lot of receptors packed in there. So yeah, the peripheral is good. And people see dim objects that way and flickering. Dan's question concerned the recent 2018 events. I think it was Chelyabinsk, wasn't it, in Russia? And where there were multiple explosions. And he said that he watched a NOVA program that actually said that it came from the direction of the sun, and that's why it had not been detected, really. I don't know about the satellite that you mentioned, if that was such or not. We have some satellites that orbit the sun, several of them. And I think the reason they don't detect it is these things are just fairly small. They're dark, and especially ones that are not part of, not in the ecliptic. Nobody looks at them, and we just don't expect it. So there's so many things that we don't expect and we learn from, and some of these things that come very close to triggering wars. The sun's coming up, and it looks like a fleet of Russian bombers, and SAC is on DEFCON 4 and all this type of thing. So the same thing happened on the other side. And the people who are cautious, fortunately, have prevailed in thus far in those things, a lot of them. So I don't think we necessarily know a lot of the Earth-crossing asteroids. There still could be many that we don't know about. And we discovered them just in the past year. There have been a couple that came within just a few moon orbit distances that we didn't see, we didn't spot earlier. Yeah, the other thing that we all worry about, we don't talk about it, is the Delta variant. So when we go out, I'm glad to see you wearing a mask. I've been jabbed 4 times, and 3 times were for real because I'm part of the Pfizer testing program. So even so, we all have to be careful, and for various reasons. Many of the masks are not perfect, and none of them are perfect, but some are more perfect than others. And there's a lot to consider. So we do have to maintain some distance. And if any of you see situations where we are forgetting that, just say something, or you want to add something. Okay. Well, thank you. Nice to meet you.